Thank you very much, Autodesk, for having us today here and holding that event, and for your contribution to the innovation and integration of BIM into the construction industry. Today, we are here to talk about how do we use BIM in the expansion of museum project and Tsui East. The expansion of the Hong Kong and Science History Museum is located in the eastern side of the Kowloon Peninsula, and it will act as the inland anchor of the cultural look of TST district. It will enhance the current cultural venues of Hong Kong, like the Hong Kong Museum of Art near the harbour, or the new cultural venues in the West Kowloon district, such as M+. The expansion of the museum is a commission from the Architectural Service Department that is working, that is the working agent for the client, that is the Leisure and Cultural Service Department. Our task is to design new annex buildings and renovate the existing facilities. The expansion of the museum will double the exhibition spaces and will provide new educational facilities, new supporting facilities, ancillary car park, and a roof garden. There will be 3 annex buildings with 5 stories above ground floor and 2 basement levels. The external spaces will be rejuvenated, and they will be enhanced to create better places and more accessible places to the public. The design will also provide a holistic outlook to the existing facade through an uplift of the facade. But how do we integrate BIM into the project? We need to look at what happens currently in the Museum of the Science and History. The current museums work as 2 separate entities. They are segregated, and the design idea of this project is to bring them together through the common goal of science and history, exploration, knowledge, and resonance. We propose to enhance the relationship between the 2 buildings in order to create shared facilities that create new synergies and opportunities. The same idea of integration is the inspiration for the project team to integrate BIM into the project. We need to integrate BIM into the whole life cycle of the building by adopting BIM methodology. We need to integrate the client and our stakeholders. We need to integrate the needs into the requirements of the project for a better asset management. We also need to integrate the AS industry and make possible that the people, the society also collaborate with BIM tools. In this project, there is the ambition of integrating past to future, history to science, by creating a digital twin of the museum with the client stepping into Web 3.0 and Metaverse. As any other project, management is very important. A BIM execution plan fosters improved project management. We define the major BIM goals and how to use BIM. We need to collaborate with our consultants, and we need to set up a model in order that we can do 3D coordination, class detections. In this case, we are showing like the BIM models produced by the different disciplines. We have the architectural model, MEP model, that it will be subdivided into the different disciplines. We have a facade model and a structural model. We also need to look into each individual element, all these building components that make that BIM model, and at the end, make the project that it will be built. We look into management of parametric families. Like, for example, here is the doors that we are using, that they are able to report to us geometrical data. They are able to report to us finishes, statutory requirements like fire rating requirements, and analysis results. With these BIM models, we carry out 3D coordination and class detections. Autodesk Class Detective tool performs inspection, identification, and reporting of interference in building geometry. These classes are collected, and we generate a class detection report that later we review in our BIM workshops, and then we find solutions in order that we find those solutions before we go to site. It's clear that there is a series of benefits to class detection. We minimize on-site risks, reduce wastage. We enhance our client satisfaction and we mitigate risk. Reduce manual tasks and error preventions. Important, cost saving and be more time efficient. And of course, enhance the safety and improve our collaboration. One of the challenges of this project is to maintain the museum partially open to public during the construction and during the renovation works. Therefore, phasing planning and 4D modeling is very important in this project. BIM helps to visualize the construction sequence for better and easier communication with the client. We also, with BIM, carry out structural, lighting, and traffic analysis. And as any other project, we need to collaborate with the client, with the stakeholders, with all the different consultants, and everybody that is part of the project. We, in Farrells, we are the lead consultant in this project, working with the Architectural Service Department, but we are also the BIM manager of this project. And then we need to set up the way of working. We work in the cloud. We work with the common data environment, BIM 360, and we define the workflow for our firm and also for our sub-consultants. We work in BIM, collaborate in BIM 360, that is compliant with ISO 19650, and then thanks to it, we can set up different access. Which party can access this information, which party cannot access this information. Information that is stored in the cloud, in the CDE, in different layers of information, documentation, graphical data, or non-graphical data. We can approve, authorize, or verify data in the CDE. Setting up workflows and methodologies in BIM, we integrate the design and BIM technology. Since our original BIM kickoff meeting, through the development of the BIM execution plan at the initial point of the project and later when the contractor will be on board, we will carry out design coordination, class analysis, and BIM workshops. We need to thank Autodesk for giving us the tools to be able to join this BIM journey. As a common data environment, CDE, in this project we use BIM 360. As a tool to carry out class detection and advanced coordination, we use Autodesk Navisworks Manage. As a design authoring tool, we use Revit. We use AutoCAD because we also need to have easily accessibility to those subcontractors that are not yet involved in Revit. And also, we work with traffic consultants, and Autodesk vehicle tracking help us to review, for example, vehicle sweat paths. But we also need to embrace open BIM. We need to work with other platforms. We need to be able to exchange data between different platforms. And Autodesk facilitates also that to us. We can manage data with Dialux and Excel. We can carry out lighting analysis with Dialux Evo. Using IFC formats, we can carry out a structural analysis exporting the data that we have from our Autodesk Revit models. We believe in innovation, and I think it's the way forward. We need to innovate in our projects. We need to innovate in BIM. Early coordination in BIM allows us the possibility of implement, for example, MEP DFMA modules, like this MEP integrated service riser, or this modular condensing pipe work with cooling tower. Or also structural DFMA modules, like the precast slab that we are using at one of our annex. We work with the plugins and the tools to make a more efficient work. Autodesk Revit Cross Dynamo provide us visual scripting to automate manual tasks. And at the end, provide a better project if we can reduce the iteration of extra work. For example, visual scripting can assist us to check statutory requirements, such as MOE travel distances, or create foundation models from a piling schedule. Autodesk Revit Cross Enscape enhance our visualization skills, improve our visualization to be able to communicate with consultants, with our client. We can instantly have real-time rendering and visualization to do materialities studies or to do lighting studies in the project. Autodesk Revit cross-die routes boost our efficiency and productivity. It's important, the management of the families, the management of the parameters, and be able to export those sheets that are going to be part of the documentation, of the tender documentation. Autodesk Revit cross Pywide Revit can automate manual tasks inside the Revit environment, like generating the pattern of the paving that we are using in the outdoor of the museum. Autodesk Revit, with Revit, we can directly, following very easy steps, to print our 3D models that we will use for communication with consultants, with the client, and also for us to improve the design. Or carry out our engineers cooling load simulations. And all that BIM bring us benefits to the project. We believe that in this project, we realize that enhance our visualization and analysis, improve our collaboration and communication, reduce project risks, improve project efficiency, improve project outcomes, and enhance our client satisfaction and the product and the building that we deliver to the society.